All right. All right, so we'll talk about general arachnid morphology or anatomy. And these features are going to apply to ticks and mites in the same way that they would apply to spiders or scorpions, although no, scorpions are not arachnids, but they would also apply to pseudoscorpions, to some of the other arachnid groups. So body's divided into two parts. In crustaceans, we call those 2 points the cephalothorax and the abdomen. In arachnids, we call those oftentimes the gnathosoma and the idiosoma, or sometimes you'll see the prosoma and the abdomen. So there are a number of different names for that, but I like this one, the gnathosoma, which means jawed section, and then the idiosoma, which means body section. And so most of arachnids have 8 legs, and you can see that some, are modified from that plan. They're attracted to carbon dioxide, and this is an important one and actually helps to clue ticks and mites into where their hosts are. The molt stages are called instars. This is true of most arthropods. We use this term. Larval instars are called nymphs, and typically not larvae because they are not completely morphologically different than the adults. They're just bigger versions of the adults. Bigger versions, sexually mature, or the larvae are smaller, sexually immature versions of the adults. The adults are large, sexually mature versions of the nymphs. All right, so you have different numbers of hosts in the life cycle. Ticks tend to be less species specific than what we saw in a number of our insect micropredators. All right, pathogenesis. And so here are some pathologies associated with ticks. The last one are the most common when you're referring to really large scale, pretty devastating pathologies associated with ticks. A lot of it has to do with secondary infections. Secondary infections or something passed by the tick that the tick is a vector for something else. Those are most often. Anemia is fairly rare, especially with an animal our size, maybe with an animal his size, but an animal our size, you'd have to have a lot of ticks feeding really heavily to experience any level of anemia. Dermatosis, inflammation, that's going to be fairly common. Tick paralysis, this can be fairly common, but it tends to be short-term, short-lived paralysis. Otoacariasis, infestations in the ear canal, and these can lead to serious secondary infections. But yeah, the infections, these are the most common. These are the things that you tend to think of when you think of ticks. And so I want to ask you this. When you think of ticks, what do you think of as far as their danger? Do y'all think of Lyme disease? Do y'all know what Lyme disease is? You heard of Lyme disease before? And so Lyme disease is a spirochete that's transmitted. The spirochete is Borrelia burgdorferi. We'll talk about that in a little bit. But a spirochete bacterium transmitted by ticks. And so a lot of these ticks act as vectors for some pretty dangerous organisms. So let's talk about some of these. Ixodes scapularis, the black-legged tick. So on the left is just a gross anatomy of the tick. On the right is a zoomed-up version of the hypostome. And so this is the primary vector for Lyme disease, Borrelia burgdorferi. And of all of the tick-borne diseases, this is one of the more common in North America, and it's also one of the more dangerous in North America. It also acts as a vector for Ehrlichia species, which causes a disease called human granulocytic ehrlichiosis. And so, these are ticks that can be vectors of pretty dangerous organisms, but for the most part, the pathology associated with the tick itself is fairly low. So here's the life cycle of the tick. Notice that we don't refer to the juveniles as larvae. They have a life history very similar to the adults. The nymphs oftentimes feed on host as well. And so with a lot of our insect organisms that we have historically referred to as parasites, we went through kind of piece by piece and talked about how a lot of those are more micropredators than they are parasites. Ticks are oftentimes very obviously parasites, that they will latch on and feed on the host for a long period of time before they either leave because they were displaced or they leave because they had to lay eggs somewhere or something else. And so here's the distribution of this genus, Ixodes. And so you do find some cases of Lyme disease in California, but most of them tend to be restricted to the northeast in that area. Lyme, Connecticut, the disease is named after a place in Connecticut called Lyme, Connecticut. And that's where most of the cases are. You do find some in the Midwest. Some of the primary research institutes are in St. Louis. And then here is the telltale bullseye lesion associated with Lyme disease. Now, you don't always get this, but it's in most cases of Lyme disease. Around the site of the tick bite, you get a bullseye-shaped inflammation, and that is very characteristic of Lyme disease. Man, it doesn't always show up, but when it does, it clues you into that you're dealing with Lyme disease. All right, so last week, and not the week before, because the week before was Thanksgiving week, but the week before that, we spent some time talking about transitioning from a free living to a parasitic lifestyle, right? Do you remember talking about that? And even, Hannah, you talked about that during the discussion that you led last Wednesday, that transition from free living to parasitic. And so think about that in regards to ticks. So if ticks weren't feeding on blood, what would they eat? What would they eat? So as you think about an organism transitioning from free living to parasitic, it's not just a matter of, feeding off of a host versus, feeding off of something else. You have to also think about what they're designed to do. And this is where ticks and some other organisms just are interesting. I mean, they look really, really well designed for attaching to the host. But, we also talked about how you can modify some of those forms. Dermacentia andersoni, the Rocky Mountain wood tick. This one always makes me think of Dr. Anderson because somebody named Anderson named this tick after themselves. And I never understood that desire to name a parasite after yourself. I could understand naming a parasite after another person, maybe somebody you didn't like. I mean, maybe that was the case. Maybe somebody that really didn't like somebody with the last name Anderson named this after them. But all right. So again, the nymphs are parasitic. The adults are parasitic. They tend to shift hosts throughout their life cycle, throughout their life history. This oftentimes causes the tick paralysis that tends to be associated with some tick species. Vector for Rocky Mountain spotted fever, which can be incredibly dangerous, even fatal. Also a vector for tularemia, which is also can be incredibly dangerous and even fatal. But for the most part, they tend to be treated fairly successfully and fairly well. Same genus, different species, Dermacentia variabilis. This is called the American dog tick. It is not the most common tick to find on your dog, and so it does prefer to feed on dogs, which is why we refer to it as the American dog tick. But it is not the most common tick. You may or may not have ever interacted with this if you've removed ticks from your dogs. Also transmits Rocky Mountain spotted fever and tularemia, like the other species in this genus. Has a similar range. Find it in the eastern U.S., but extending up into the northwest and you find it along the Rocky Mountains, which makes sense considering the name of the disease. Also causes tick paralysis. That's interesting, the whole projector shifting around because there's somebody jumping up in 20. So here's Rocky Mountain spotted fever caused by the bacterium rickettsia, treated well with doxycycline, but in immunocompromised people or in people that their bodies are taxed for other reasons, children and those that are older, it can be incredibly dangerous and even fatal. Rhipicephalus, it's a tick. So this is of all the dog ticks that you find on your dogs, this has the widest distribution. Doesn't necessarily mean that it is the most common of all of the dog ticks, just that it has the widest distribution. Transmit East Coast fever, which is a disease caused by Theileria parva to cattle. And so again, you're kind of getting this theme that these ticks tend to be generalist parasites. What do we mean by that? A generalist parasite. And you're like, well, what do you mean by that? Because you said it, I didn't say it. Right? What do I mean when I say it is a generalist parasite? And a lot of these ticks tend to be. Yeah, they're not host specific. And in a lot of ways, and a lot of ticks are this way, they really don't care what it is as long as it's a mammal. And you're like, well, then they care what it is a little bit. But a lot of these, as long as it's a mammal, they'll feed on it, which is interesting. All right, Pathophysiology annulatus, the American cattle tick. Look at this. Look at the structure of its legs. Very extreme, extremely adapted for holding fast. This is Pathophysiology annulatus. So notice eradicated from the U.S. in 1939, but it is found in Central and South America and elsewhere, and it is kind of moving back up as its range expands. Transmits Babesia bigemina, which we talked about several months ago, at the beginning of our semester, which causes Texas cattle fever or red water fever, and is rapidly fatal in cattle. And so this is one that ranchers worked really, really hard on eradicating and did so successfully back in the 1930s. One of the big wins for parasitology way back when. Do you know what school in the United States is known most for research in parasitology? So think about what makes a parasite important. Economic or medical. And when you're talking North America, which one of those two importance factors is more common? Economic. Okay? So now think of some states that are well known for agricultural industry, and then try to answer this question of what university is best known for its parasitology heritage. I'll give you a hint. The mascot is the Cornhusker. Nebraska. The University of Nebraska. University of Nebraska and Oklahoma University have some of the best parasitology programs in the country, and it's because of the heritage of that, where this was a big win for the University of Nebraska's parasitology program, eradicating this tick from the United States. Ornithodora species, these are soft ticks. Instead of having a really hard cuticle, they have a really soft cuticle, similar to what you get in a soft-shell turtle. Have any of you seen a soft-shell turtle before? Have any of you eaten soft-shell crab? So soft-shell crab is a little bit different of a story. In a soft-shell crab, that right there is a seal. In the next slide. A soft-shell crab is a crab that's in the middle of molting. So it molted and it's rebuilding its cuticle, but it's still really soft. And you just boil the whole crab, and then you put it in like a sandwich. They'll bread it and deep fry it. Not boiled, usually deep fry it. and you'll eat it like on a sandwich, like a po' boy, but you'll do a soft shell crab. And it's similar to that in that it's a real leathery shell and it's not real hard, but you don't eat it. So it's an important vector of another species of Borrelia, Borrelia recurrentis, which again we talked about several months ago, causing relapsing fever, another really dangerous disease, not quite as extreme as Borrelia. Wow, and now I can't think of the other species name. Oh, Babesia bigimina. Oh, this is Borrelia recurrentis. This is Borrelia burgdorferi. Sorry, the same genus as the causative agent of Lyme disease. Harlarachni species, seal lung mites. So now we're transitioning from ticks into mites. And as we make that transition, you have to keep in mind that the difference between ticks and mites, the biggest one, is that ticks are macroscopic, visible with the naked eye. Mites are microscopic and not visible with the naked eye. And so you've got this genus here, Harlarachni species that live inside of the lungs of seals. Here's a very sad looking seal for you to demonstrate some of just the pathology of this. So this would be one where it is a parasite that is not medically important. It is a parasite that is not economically important, but it is a parasite that is ecologically important. So one that's just starting to show up on the radar of parasitologists, which is how it ended up in the textbook, and from now will just continue to grow as seals play an important role in the ecosystem. This is one that is not medically important, it is not economically important, it is not ecologically important, but it is pretty devastating when you find one of these. So Demodex folliculorum, the follicle mite, these live in the follicles, the hair follicles, usually in your eyelids, where your eyelashes are. So you can see in a heavy infestation, you can get a lot of inflammation in your eyelids, and you can start to build up a lot of goop, a kind of a byproduct of these mites feeding. And so you can get kind of a goopy eye and a lot of inflammation around the eyelids. And then as you start to squeeze, you can actually squeeze out some of these mites. And these are mites that are visible with the naked eye. Most mites are microscopic. You can't see without a microscope. These Demodex brevis, you can actually see them. And Demodex folliculorum, you can see with the naked eye. Very high prevalence, 20% in young people, 100% in older populations. And so, but usually in low enough numbers that you don't really notice them very much. Have you ever been looking at a microscope and it looks like you see something move across your eye? So a lot of times you'll have mites on the surface of your skin and on your eyes, and they'll move across and you'll see them a little bit. But you have to be focusing on something that's going to really help you to see something moving across your eye. Otherwise, you never even notice them. But yeah, we've got lots of mites that like to live on our bodies and use them for particular things. Trombicula, chigger mites. So only the larvae are parasitic. The adults are large, and these cause chigger dermatitis. And so the larvae burrow underneath the skin and feed. And as they do, our immune system reacts to their presence and triggers the inflammation known to a number of parasites. That is somebody with chigger mites. And so you could see in each one of those sources of inflammation, there's probably one or a couple of these mites, Trombicula species. All right. Sarcoptes scabiei, the itch mite. This is probably one of the most common mites. It does. One of the most common mites to have as humans. And it is fairly common in dogs. In dogs, it can very quickly become a very heavy infestation and can very quickly become fatal to the dogs. And so do you see the body of this mite? You know what it reminds me of? Have any of you seen the movie Up? No, I'm sorry, not Up. WALL-E. Just kidding, not Up. WALL-E. So in WALL-E is the movie revolves around a robot named WALL-E and another robot named Eva. And WALL-E follows Eve onto through space, basically onto a rocket ship, where the rest of the human population is living and waiting out conditions on Earth to improve. But they've lived on this rocket ship for several generations, and living in space, your bone density decreases. And so this is basically what the people look like, but a human version of this tick. Do you see the 8 legs on this tick? You see 4 of them down at about halfway through the body, just kind of hanging there as really useless appendages in this great, enormous body. What's that? That's a mite. Yeah, the legs are right there. Yeah, and so it's just, I've always enjoyed seeing this mite's body with really useless limbs. You can see that this is really well modified into living burrowed underneath its host skin. So here's the pathology, a really heavy infestation in a dog on the right, where most of its legs and a good deal of its body is inflamed and a lot of hair loss. And then you can see a human there with the back of their neck with some of these mites living underneath them. So they tend to infest or infect the areas without fur, without hair. And secondary infections become pretty common, but just the feeding of these mites alone can be enough to cause extreme weight loss. Infections readily spread from individual to individual. And so this is known as scabies or scabiasis or mange, sarcoptic mange, and this is probably one of the most dangerous of all of the mites. So ticks oftentimes act as vectors of other illnesses. Mites rarely do. And of all the mites, this is probably the most dangerous. This is another mite, Dermatophagoides, the house dust mite. And so these are the most common mites to find in humans. And they do go in your house. Yep, but they're teeny tiny little organisms. And so, most people that have a dust allergy, what you're actually allergic to are these mites in the dust, and usually not the dust itself. Because a good percentage of dust is dead skin cells. And if you live in the house, a good percentage of the dust are your dead skin cells. And so usually what it is that you're allergic to is the presence of those mites and not necessarily anything else that's in the dust. All right, well that's all for our mites. And so unless you all have any questions, I think we may end here and just push the rest of what I was going to do today to Wednesday when Shelby leads our discussion. Shelby, do you have any questions as far as, have you started pulling papers at all for your discussion? Okay. Well, as you start to pull those, let me know if you have any questions. Keep in mind we have our last of our research abstracts due next week, and then we'll have our last discussion on Wednesday. And again, our final exam will open up next week on Monday. Our quiz will close next week on Monday.